answers. Both answers will solve that equation. But here's the scenario I'm dealing with now. I'm just saying, hey, what's the square root of 4? Well, because I'm saying, if I'm not being specific, then if you see this written, I'm asking you to do this. Give me the positive square root of 4, which is 2. Again, if I say find all the possible answers, then I'm telling you I want all the answers for the square root of 4, which is plus or minus 2. So I have to tell you specifically. In other words, read the directions, unlike what I did, and you'll be okay. All right? Now here I'm just saying simplify. So I don't need to worry about plus or minus, and that's what this little chart up here, this little statement up here is kind of telling you. Okay? If a radical is more than one root, the radical sign indicates only that positive or principal root, which means I just want the positive one, that's it. I don't need anything else unless I tell you find all the solutions. Okay, so with that being said, let's start simplifying. This is where the real stuff happens. So I'm going to start simplifying this guy, the 4 times the square root of 320. So here I need to, again, find what numbers do I multiply to get 320. Well, one thing I can see right away is 320, 20 goes into that. So I'm going to break that up, and I know that is actually 16 times 20. Again, you just got to find numbers and multiply to give you 320. Once I do that, I say, well, 16, that is a perfect square. So I have 4 times 4 now. 20, well, that's going to be 4 times 5. So the square root of 4 times the square root of 5. And again, I did that because 4 is a perfect square. So I wasn't done yet. So I was able now to write this as 4 times the square root of 4, which is 2, times the square root of 5. So 4 times 4 is 16. 16 times 2 is 32. So I get 32 square root of 5. And that's going to be my final answer. Okay, so that's number 2. And again, that should be fairly familiar because you've dealt with lots of simplifying square roots before. So this is kind of the same situation. Now when we get to cube roots and fourth roots, now I'm going to have a slightly different approach. So I'm going to kind of talk about how we're going to do that. And again, there's not one right way to do this. You may go and watch some YouTube video and they do this differently. And it doesn't make me wrong or them wrong. There's just different ways of solving these. So please be aware of that. And if you don't like the way I do it, feel free to look up some other videos and see how that works. Okay, so I have my cube root of negative 250. Here's the way I like to simplify this. First off, I'm going to break this up to negative 1 and 250. Because I know the cube root of negative 1 is negative 1. So I already got that negative taken care of. Now, my 250, I need to find a number that I got to break this out down, but the key on this as I'm doing this, because it's now a cube root, I don't want to find a number that multiplies twice. I need to find a number that multiplies 3 times. Well, I know 250 is divisible by 25, so I'm going to break it up as the cube root of 25 times the cube root of 10. And I'm going to start breaking that down. So again, I already have that negative 1 pulled out. This is now the cube root of 5 times 5. And then 10 is 5 times 2. So notice, I have 3 5s. As long as I can get 3 of them, I can pull it out. And just again, to understand how this works, I normally don't write this next step down, but I want you to see it. This is the cube root of 5 cubed. And because the power and the root match, I can write this as 5 to the 3 over 3, which is 5 to the first. So my next step, this is what I normally write. It's negative 1 times 5 times the cube root of 2. Again, I'm just showing some of the work of how I got that, which is just negative 5 cube root 2. Again, I'm showing some extra little work here that hopefully that doesn't confuse you, but I want you to understand what the heck I just did in case you have that question. And I'm not there to answer right now. So that's going to be number 5. All right, now we're dealing with cube roots. Now fourth roots, same thing. Just now I have a fourth root. I need to find a number I need to multiply by itself 4 times. And with this one, 162, I know I can at least divide it by 2. So I'll start there, which is actually 81 times 2. So this is going to be 3 times the fourth root of 81 times the fourth root of 2. Now, again, to break this down, I can see this one right now because I actually know this is one of those perfect fours. This is where you have that chart up there. It's going to help you out. We actually dealt with this one earlier, and that's what you'll notice is some of these numbers pop up again and again. So I've dealt with the fourth root of 81 already. Which again, just to show where it comes from, though, it's the fourth root of 3 times 3 is 9, and 3 times 3 is 9 again. So there's actually 4 3's here. So I'm writing them down. And then copy down that fourth root of 2 as well. So you'll notice I have 4 3's. This is where I want you just to know that's 3 times 3. And then don't forget your fourth root of 2. So that's 9 times the fourth root of 2. Done. So that's number 7. So that's dealing with cube roots, fourth roots, and square roots. Again, square roots are probably the easiest because you know your perfect squares. These other ones, you may not know all the perfect cubes, the perfect fourths. If you do, then it will save you time. Now, the last one to deal with are radicals with variables. And these are actually, I find these to be easier. But again, one thing to be aware of before we start, if you're dealing with square roots, make sure when we simplify these, we need to find exponents have to have multiples of 2. Cube roots, the exponents have to have multiples of 3. And fourth roots, your exponents must be multiples of 4. Okay, so starting off here with number 10, I'm going to deal with these. This is now a square root. And as I said, these are actually a little bit easier, you'll notice. Maybe not at first, you got to get used to it, but they are overall easier. The numbers are this, we can deal with the numbers the exact same way we normally do. 324 is actually, if I'm just messing around with some numbers here, it's 36 times 9. So I'm going to break that up as the square root of 36 times the square root of 9, which are both perfect squares, so that's kind of nice. Now, here's the deal. Right now, if I wrote this a cubed out as a fractional exponent, don't write this because it's not going to help you. This is actually 3/2, which that's not really deemed simplified, having a fractional exponent. But what I can do is I can do this. I can break this a cubed up into a multiple, or one of the exponents has a multiple of 2 in it. So that would be the square root of a squared and the square root of a. So notice I just broke that 3 up, and I can simplify one of those, not both of them, but I can simplify one of them, and I'm going to do the same thing with my b. I'm going to take this and write this as the square root of b to the 6th times the square root of b, well, to the 1st. 6 plus 1 is 7, so I just broke it up. So as I simplify these, you'll notice I'll be able to simplify my 36, my 9, my a squared, and my b to the 6th. And the a's and the b will be in its own radical at the end. So the square root of 36, well, that's going to be 6. The square root of 9 is 3. A squared, this is in the square root of a squared. Give you a quick reminder here. This is a to the 2 over 2. By the way, the b to the 6th, that's going to be b to the 6 over 2. So when I simplify, you'll see that this will be now a to the 1st. Let me change colors back here. So it's going to be a to the 1st. So I've gotten these 3 taken care of. And b to the 6th, that's going to be b to the 3rd. 6 divided by 2 is 3. So you see the only 2 left over are my square root of a and my square root of b. So simplify all this out. I have 18 ab cubed and then the square root of ab. And that's number 10. Again, I got a couple more to work through here, but it's really going to be the same premise on these last 3 that I have. So number 14. So now I have a cube root, negative 81, p squared, q12. Okay, so on this one, again, I'm dealing with a cube root. Pay attention to that. But one thing I'm going to do, break up that negative. So this is going to be the cube root of -1. And my 81 I know is 9 times 9, which there's only 2 of those. But I can do 3 to the 4th. So I'm going to, because this is, again, that's a perfect fourth. So I'm going to write this as the cube root of 3 to the 4th. Again, I said there's a lot of ways you can do it. You can write as 3 times 3 times 3 times 3 if you want. I don't care. But keep going here, and I'm going to deal with my variables. The p squared, I don't have enough p's to actually pull that out. I have to have at least 3. So I can't really do anything to that. Don't try to overthink it and try to make something work that can't. But this 12, I will be able to simplify that. 12 goes into 3, so I don't have to break it up or anything. So that's actually kind of nice. I just got to write it correctly. There we go. Okay. So as I simplify this, first off, 3 to the 4th, well, that is a cube root of 3 to the 3rd times the cube root of 3 to the 1st. I had to break that up a little bit, but now I am good to go. I just want to copy these down so you can follow along with what I'm doing. Okay, so first term, the cube root of -1 is -1. The cube root of 3 to the 3rd is 3. So now I have -3. The only other thing that I can pull out is this q to the 12th. And remember, this is actually going to be q to the 12 over 3. So that's going to be q to the 4th. So I'm going to write q to the 4th here. And the only 2 terms left over that I can't simplify are going to go in my radical. It's going to be 3p squared. And I'm done. So that's simplifying a perfect cube. And the last ones I got 2 of them here. 18 is actually the easiest, but I just want to show it. But I got my perfect fourths. So number 17, I'm going to start with my 625. And one thing you'll notice is that is divisible by 25, so it's probably a good place to start. So on 17, I'm going to write the 4th root of 25, and it's actually 25 times 25. So you might be able to kind of skip a step here if you want, because I can see right now that's 5 squared and 5 squared, so that would be 5 to the 4th. It's going to save you some work there if you just write it as 5 to the 4th. And you can look at your chart up above. You wrote it and have everything filled out. You can kind of see. But next up, I have c to the 23rd. So I'm going to break this one up as something that's, obviously I know 20 is divisible by 4, so I'm going to go the 4th root of c to the 20th, and then I'd have 3 left over. So it's going to be times the 4th root of c cubed. And then same thing in my d to the 11th. I know 8 goes into 11, or 8 goes into 4. 4 goes into 8. Sorry, I can't say it right. 4 goes into 8, it doesn't go into 11. So I'm going to write this as the 4th root of d to the 8th times the 4th root of d to the 3rd. Okay, so again, I can pull out this 5 to the 4th, the c to the 20th, and the d to the 8th. So those are the 3 terms getting pulled out. So I'm going to have 5, and then c to the 20 over 4, 20 divided by 4 is 5. D to the 8 over 4 is d squared. And those are now pulled out, and we just have the 4th root of c cubed d cubed. And that's 17. And I got one more left here, number 18. This is actually the easiest. Notice it's just basically one big binomial, but it's raised to a power, and that is the key. If you have it raised to a power, just literally think of it like this. It is 8 over 4. It's power over root, so that's going to be y plus 3 squared. Done. I told you 18 was the easiest. I just don't want that to freak you out if you see a binomial sitting there. So that is our first unit on radicals. There is an assignment attached to this, so this just ensures that you all saw it. If you just went through the notes, if you didn't get the homework, well, you didn't go through the notes. I'll know that. Be pretty clear. So your homework